Greetings from K.S.Rangasamy College of Technology. Myself B. Balaji, working as assistant professor in the Department of Mechanical Engineering at K.S.Rangasamy College of Technology. I am handling the research on mechanical transmission system subject. Today we are going to discuss about the topic of gear under the module of design. First, introduction of gear. Gears are toothed wheels used for transmitting motion and power from one shaft to another when they are not too far apart. Compared with belt, chain, and friction drives, gear drives are more compact. It can operate at high speeds and can be used where precise timing is required. When large power is to be transmitted, then gear is to be used. Next, definition of gear. A circular body of cylindrical shape or that of the shape of frustum of a cone and of uniform small width, having teeth of uniform formation and provided on its outer circumferential surface is called a gear or toothed gear, or otherwise you call it as toothed wheel. So these are the types of gear. First one will be a straight spur gear, second one will be a helical gear, third one will be a herringbone gear, and then plain bevel gear, and then spiral bevel gear, and then hypoid gear, and then planetary gear, worm and worm wheel gear, and then rack and pinion gear. So these are the types of gears. These gears are used according to its applications. According to the applications as well as the processes. Next one will be classification of gears. Classification based on the relative motion of their shaft axis. First one will be parallel shaft. Example, spur gear, helical gear, rack and pinion, herringbone gear, and internal spur gears. These comes under the parallel gears. Next one will be intersecting gears. Example, bevel gear and spur gear comes under intersecting gears. And then classification based on the relative motion of the shaft. First one will be row gears. The motion of the shaft relative to each other is fixed. Second one will be planetary and differential gears. Planetary gear means combination of two or more gears is called as planetary gears. Differential gears. Differential gears means left and right side wheel. When you are turning means right side wheel have to cover more areas. So different in that areas differential gears to be used. Next one will be a classification based on peripheral speed. Low velocity gears have less than 3 meters per second. For medium velocity gears, velocity is 3 to 15 meters per second. For high velocity gears, velocity range is more than 15 meters per second. Classification based on the position of teeth on the wheel. First one will be straight gear, second one will be helical gear, third one will be herringbone gear, fourth one will be curved teeth gears. Next one will be classification based on the type of gearing. Rack and pinion gear comes under the type of gearing. Gear nomenclature. So, in gear nomenclature, there are some terminologies like addendum, dedendum, face width, top plant, circular pitch, tooth thickness, clearance, dedendum circle, addendum circle, clearance circle, width of space, pitch circle, flank, face, bottom width. Some important terminologies we are going to discuss about in the next slides. First one will be pitch. In that there are three methods. One will be a circular pitch. For that formula is PC equal to pi d by Z. PC means circular pitch, D means diameter of pitch circle, Z means that represents the number of teeth on the wheel. Next one will be a diametral pitch PD. PD equal to Z by D, or otherwise equal to pi by PC. Third one will be a module pitch M. M is equal to capital D by small z. Which means that module is defined as the ratio of pitch circle diameter to the number of teeth. While designing the gear, module is to be fixed first and it has to be standardized. Standard value is to be used. Next one will be total depth. In addition of addendum dedendum is called as total depth. Backlash means the difference between the tooth space and tooth thickness is known as backlash. Next important terminology is pressure angle. The angle between the common normal of two gear teeth at the point of contact and the common tangent at the pitch point is called as pressure angle. The standard pressure angles are 14.5 degree and 20 degree. So we have to use these two angles only. Either we have to use 14.5 degree or 20 degree. Next important terminology is arc of contact. It is the path traced by a point on the pitch circle from the beginning to the end of engagement of a given pair of teeth is called as arc of contact. The arc of contact consists of two parts. One will be a arc of approach, another one will be a arc of recess. Next one will be velocity ratio. Velocity ratio is defined as the ratio of number of teeth on the driven wheel to the number of teeth on the driving wheel. I is equal to NA by NB or ZB by ZA. Next terminology is contact ratio. The ratio between arc of contact to circular pitch is called as contact ratio. The advantages of gears is, first one will be there is no slip. So exact velocity ratio is obtained. When you are using the gear, there is no chance for slipping when compared to other drives like belt drive, chain drive, etc. Second point is it is capable of transmitting large power than that of the belt and chain drive. In gear drive, large power can be transmitted when compared to belt or chain drive. Third point will be it is more efficient up to 99% when compared to belt and chain drives. Fourth point, it requires less space as compared to belt and rope drives. So gear drive occupies only less amount of space. Fifth point, it can transmit motion at very low velocity, which is not possible with the belt drives. Next one will be limitations of gear. The manufacture of gears require special tools and equipments. So next one will be manufacturing and maintenance of cost are comparatively high. The error in cutting teeth may cause vibrations and noise during operations. So for manufacturing gears, we require special tools and equipments. When compared to other belt drives and chain drives and rope drives, we no need of require special tools and equipments. Like that, the manufacturing and maintenance cost is high in gear drive. Again, when you compare to belt or chain drive, the cost of maintenance and manufacturing is less. The error in cutting teeth may cause vibrations and noise during operation. Next one will be a law of gearing. The law of gearing states that for obtaining constant velocity ratio at any instant of teeth, the common normal at each point of contact should always pass through a pitch point, which means that fixed point, situated on the line joining the centers of rotation of the pair of matting gears. Next topic is gear materials. The gear materials are broadly grouped into two groups. They are metallic and non-metallic materials. First, we are going to see about metallic materials. In metallic materials, first material is steel. The most widely used material in gear manufacture is steel. Almost all types of steels have been used for this purpose. It having property of toughness and tooth hardness, steel gears are heat treated. If BHN is less than 350, light and medium duty drives. If BHN is greater than 350, heavy duty drives. For medium duty applications, plain carbon steels 50C8, 45C8, 50C4 and 55C8 are used. So these are the grades of plain carbon steels. For heavy duty applications, alloy steel grades like 40CR1, 30Ni4CR and 40Ni3CR1 and 40Ni3CR 65MO55 are used. Second material is cast iron. It is used extensively as a gear material because of its low cost and good machinability and moderate mechanical properties. Large size gears are made of grey cast iron of grades FG200, FG260 or FG350. Disadvantages of cast iron is it has low tensile strength. So next material is bronze. It is mainly used in warm gear drives because of the proper ability to withstand heavy sliding loads. Bronze gears are used where corrosion and wear a problem. Disadvantages of bronze is it is costlier. And the types of bronze is aluminum bronze, manganese bronze, silicon bronze or phosphorus bronze. Next, we move on to non-metallic materials. The non-metallic materials like wood, rod, compressed paper and synthetic resin like nylon are used for gears. The advantages is noiseless operation, cheaper in cost, damping of shock and vibration. So these are the advantages of non-metallic materials. Disadvantages of non-metallic materials is low load carrying capacity, low heat conductivity. Next, we move on to selection of material. So while selecting the gear material, we have to follow some steps. First one will be a type of service, second one will be method of manufacture, third one will be a wear and shock resistance, next one will be a space and weight limitations, next one will be a safety and other consideration, next one will be peripheral speed, next one will be degree of accuracy required, and then cost of the material, and then impact load and longer life requirements. Next, we move on to gear manufacturing. First one will be gear milling. Almost any tooth can be milled. However, only spare, helical and straight bevel gears are usually milled. Surface finish can be held to about 3.2 micron meter. Next, gear manufacturing method is gear generating. Gear generating. Teeth are formed in a series of passes by a generating tool. Shapers are normally used. Surface finishes as fine as about 1.6 can be used. 1.6 micron meter. Next gear manufacturing method is shaping. Teeth may be generated with either a pinion cutter or a rack cutter. They can produce external and internal spur gear, helical gear, earring, bone gear. Gear molding. Mass production of gears can be achieved by molding. So again, these are some of the gear manufacturing methods. First one will be injection molding. Injection molding produces lightweight gears of thermoplastic material. Die casting. It is a similar process using molten metal. Zinc, brass, aluminum and magnesium gears are made by this process. Sintering. Sintering is used in small, heavy-duty gears for instruments and pumps. Iron and brass are mostly used for this process. Next method is investment casting. Investment casting and shell molding procedure produce medium duty iron and steel gear grease for rough applications.